Carnot engine. Suppose we have a hot reservoir at temperature T1 and a cold reservoir at temperature T2. What is the maximum efficiency possible for a heat engine operating between the two reservoirs? An ideal reversible heat engine should operate to do the required task. A process is reversible if it is quasi-static and non-dissipative. We know that a process is non-quasi-static if it involves finite temperature difference between the system and the reservoir. This implies that in a reversible heat engine operating between two temperatures, heat should be absorbed isothermally and released isothermally. Now to take a system from T1 to T2, we take a diabatic path. As if we take some other path. For example, isochoric will require lots of reservoir to make it quasi-static at each point. Now, we have a cycle having following steps. First, isothermal expansion from P1 V1 T1 to state P2 V2 T1. Second, adiabatic expansion of gas from P2 V2 T1 to state P3 V3 T2. Third, isothermal compression from P3 V3 T2 to state P4 V4 T2. Fourth, adiabatic compression from P4 V4 T2 to P1 V1 T1. A reversible heat engine of such type operating between two temperature reservoir is called Carnot cycle. Now let us find out the efficiency of such cycle. For this we need to find out heat changes and work done in each step. Step 1. Isothermal process. Thus delta U equals to 0. W1 equals to Q1 equals to nRT1 in of V2 by V1. Step 2. Adiabatic expansion. Q2 equals to 0. W2 equals to R into T1 minus T2 divided by gamma minus 1. Step 3. Isothermal compression. W3 equals to Q3 equals to nRT2 in of V4 by V3. Step 4. Adiabatic compression. Q4 equals to 0. W4 equals to R into T1 minus T2 divided by gamma minus 1. W net equals to W1 plus W2 minus W3 minus W4. W net equals to nRT1 in of V2 by V1 minus nRT2 in of V4 by V3. Now the efficiency of Carnot cycle would be eta equals to W net by Q1 equals to 1 minus Q3 by Q2. Using the above relation for W net and relation for adiabatic process, we get eta equals to 1 minus T2 by T1. This is the maximum efficiency for a heat engine. Carnot theorem. Working between two given temperature T1 and T2 of the hot and cold reservoir respectively. No engine can have efficiency more than that of Carnot engine. Note that the efficiency of Carnot engine is independent of the nature of working substance.